Assalamualaikum and hi everyone. We are final year student of Microelectronic Engineering and Electronic Engineering in University Malaysia Police. We have run a project based on agriculture theme for our EMT381 and EMT382. Our project is called Smart Plant Watering System. Hello, my name is Nur Aina Bila binti Kamsi from RK05 Microelectronic Engineering. I will discuss about introduction and objective. So the introduction is there is a need for many automated systems that are capable of replacing or reducing human effort in their daily activity and job. Here we introduce one such system named Smart Plant Watering System, which is considered as one of the most commonly used and the most beneficial automated system nowadays. This system uses a sensor along with ESP8266 Wi-Fi module and other electronic to behave like a smart switching system that sense soil moisture level and irrigate the plant if necessary. Measurement of soil moisture and temperature is done by the sensor, which forward the information and parameter regarding the soil moisture and surrounding temperature to the Blynk App on user's smartphone. The user can control the pump using a notification alert. If the level of soil moisture drops below a specific value, the Wi-Fi module sends the signal to the Blynk App in user's smartphone, which then the user decides to run a pump and a certain amount of water is delivered to the plant. Once enough water is delivered, the sensor sends enough moisture in the soil and the pump stops doing its work. The purpose of this project is to help millions of people where they can automatically water their garden plant without bothering their neighbors when they decide to go on vacation or somewhere else for extended period time. This system is useful especially for users who have a day job and travel alone, as this system can water plant only when necessary without any human interaction. Objective. The main objective of this project is to develop an automated plant watering system to solve most problems in home garden or in agriculture sector, such as controlling and saving both water and electricity. The objective to consider are to design an automated watering system that can be controlled by a farmer when they were far from the garden or farm, to develop a smart plant watering system in the field of agriculture where can reduce the human workforce and as a green or saving energy, to demonstrate the functionality of the smart plant watering system.
Hello, my name is Muhammad Faizik Kwan bin Ismail Ilyas from RK05 Microelectronic Engineering. Now, I will present the problem statement from our project. First, during day-to-day activities, many people often forget to water their plant, and thus it becomes challenging for them to keep their plant healthy and alive. Second, a farmer faces a problem on their plant, often die and do not grow well because not watered regularly. Third, a farmer will feel lazy to water their plants because they need to go to their farm themselves and watering the plant with a lot of tool. And the last one, a farmer does not know the rate of soil moisture and temperature on their farm due to soil moisture affect the plant grow where the soil moisture decrease, the normal function and growth of plant are disrupted and crop yield are reduced.
Hi everyone, my name is Nina Natranai and I am from RK86. I will explain about the components that we use in our project. These are the main components that we use. Firstly, ESP8266. This ESP8266 is a low-cost module Wi-Fi. that belongs to ESP family, which is we can use it to control our project anywhere in the world. Secondly, soil moisture sensor module. This sensor allows us to measure the volumetric water contained in soil. Next, 16x2 LCD and 12C module. This is where it will display the temperature and moisture of the soil. Other than that, transistor TIP41C. This transistor is an intermediate power consuming transistor used in submission where working circumstances of the laser signal transistor may be a minute strain. In addition, water pump this component allow us to move the water from source to the soil or to flower. Last but not least, temperature sensor, the ACE18B20. This is a one-wire programmable temperature sensor for Maxim integrated. It is widely used to measure temperature in hard environments like in chemical solution, minus, or soil.
Okay, for the methodology, this is the flow chart for our project process flow. Firstly, the temperature sensor and the moisture sensor will read the temperature and the moisture for the soil, and then the information for the reading moisture and temperature will be sent to the user by using Blynk App that can be installed from the Play Store or App Store in our device. After that, the user will decide to either to switch on or switch off the pump. If the user switch on the pump, the water will come through to watering the plant for 2 seconds. Then after that, after 2 seconds, the pump will stop, and then the sensor will continue read the moisture and temperature. But if the user not switch on the pump, the sensor will continue read from the beginning of the process. As you can see in our flowchart, we use the Blynk App to get the information from subject to the user. Now, I will explain what is the Blynk App. Blynk App is a new platform that allows you to quickly build interface for controlling and monitoring your hardware project from your iOS and Android device. With Blynk 2, the software side is even easier than the hardware. Moreover, Blynk is perfect for interfacing with simple projects like monitoring the temperature of your fish tank or turning light on and off remotely. Currently, Blynk App supports most Arduino board, Raspberry Pi model, the ESP8266 particle core, and a handful of other common microcontroller and single board computer, and more are being added over time.
Hi, my name is Muhammad Safar Mijasmi. I will explain the working mechanism of our project. We can see now this is our circuit diagram. This is the connection of the component and they were controlled by ESP8266. The program was uploaded into ESP8266 to make all the components will function as we want using Wi-Fi connection. Firstly, the pump was connected to 12-volt power supply and then connect to transistor TIP414 as a switch to control the pump. The 12 multiplied by 6 LCD was connected to pin D1, D2, ground and V in. Next, LCD will show the soil temperature and percentage of soil moisture. The important part is soil moisture sensor. It was connected to pin A0, ground and S3, then followed by DS18B to 0, or we call it temperature sensor, connected to pin D0, D7 and ground. Another important part is Blynk App in the smartphone. When Blynk App was connected to ESP8266, the reading of temperature and moisture of the soil will show in the Blynk App, and we can control the pump by turn on the switch in the Blynk App. So it is user friendly for those have a plant at home, because they can monitor and water their plant wherever they are, such as at workplace. So we will show how our project working. So here, this is the demonstration. Enjoy it. This is our project prototype. Firstly, we connect all the components to the power supply, and then we can see the LCD will light up and tell us connect to Wi-Fi. After Wi-Fi connected, it also connected to the Blynk app in our phone. The LCD will show the temperature and the soil moisture. This is the pump that pumps the water to the plant. This is the soil moisture sensor. And this is the temperature sensor. Now, we can open the Blynk app in our phone. We can see the interface of the Blynk app with the project. Blynk app also shows the value of the soil temperature and soil moisture. Also, the switch pump. Push the play button on the top of the Blynk app and it will connect to the ESP8266. And now, we can see the reading of the temperatures, soil temperature and soil moisture same in the Blynk app and the LCD. To turn on the pump, push the pump switch and it will pump the water to the plant for 2 seconds. We can turn on the pump many times until the soil moisture was increased. Now, after several times pump the water to the plant, the percentage of soil moisture was increased from 7% to 70%. We can set the value of the temperature and moisture that we want. Then, the Blynk app will notify the user if the temperature was high or the moisture was low. In that case, the user can know the condition of their plant. For example, if we set the moisture 70%, It will notify the user because the moisture for now is 7%. That means lower than the set value. So, user can turn on the pump to increase the moisture. For the temperature, we set it to 35 degrees Celsius. For example, if the temperature was increased and higher than 35 degrees Celsius, the Blynk app will send the notification to user, and user know the condition of their plant. Then, the user can turn on the pump to give more water and then decrease the temperature. This means it can monitor our plant even we was far from our plant.
This is the conclusion that we can conclude from the project that we have doing. From the project that we have worked on, we have designed an automated watering system that can be controlled by a farmer when they were far from the garden or their farm. In addition, we have developed a smart plant watering system in the field of agriculture where can reduce the human workforce and as a green or saving energy. Besides that, we also have demonstrated the functionality of this project of the smart plant watering system. Overall, the objectives of our project were achieved successfully. That's all from us. Thank you for your attention.